Well, hello. Funny meeting you here. Hello, everyone. Welcome to another installment of We Need Our Space, a special show. I guess they're all special, aren't they? But this one is a show on the deep sky objects that you can find in our nighttime sky with some binoculars or a telescope. Let me just turn the music down just a tad. Okay, so we can get going. Yes, this show is going to be about the deep sky objects. Let me minimize myself just a tad here. Whoa. There you go. Shrink me down just a little bit. Alrighty. So let us begin with our talk on deep sky objects. That is today's topic. So today we're going to look at some deep sky objects. Yes, in the past few streams here, we've looked at planets and constellations. All the standard sky viewing stuff, of course. But today we're going to take a deep dive into the sky and check out some of these deep sky objects. So it's kind of like if you were on a boat far out on the ocean. And when you look down, you'll see the ocean water and the waves, of course. Now, occasionally you will see a shark, some fish, maybe a whale breaching the surface. Well, as you know, deep down in the ocean, deep down in the water, there are all types of things. Vegetation and fish, all kinds of life, all types of undiscovered wonders. Well, the same goes for our nighttime sky. So whenever you go out at night and take a look up, you'll see the usual dark sky dotted with stars. Now, occasionally you'll see a planet or two. Sometimes you'll catch sight of a shooting star or even a comet. Well, like the ocean, we can go deeper than just the surface level. Now, in this case, you won't need a telescope because I will show you where these deep sky objects are at, and then we will fly out to them and talk about exactly what's going on. So first of all, I need to explain that a deep sky object is not an individual star or solar system. They are astronomical objects visually observed as star clusters, nebulae, galaxies. You can view these with your naked eye, some binoculars, a telescope, or any other type of device that will help you. So first off, we're going to take a look at something called M6, or the butterfly cluster. And yes, you can find this in your nighttime sky. I'm going to point this out here right now. So here we are in our summer nighttime sky. You have the Milky Way galaxy here. You can view Jupiter and Saturn over here. So over here on the southern horizon, you can find in this area, I will zoom up, the butterfly cluster. So I'm zooming in on the butterfly cluster. So the reason we call this the butterfly cluster should be obvious whenever you look at it. Now, do you see a butterfly in this collection of blue stars? Take a look at it. Maybe cock your head to the right here and take a look at it. So do you see a butterfly? Well, these are arranged in an oblong shape that suggests the wings of a butterfly. There's even a fairly obvious V formation over here for the antennae of the butterfly. Well, this is about 1,600 light years away from Earth. Here it is again over here, a different view, an actual photograph of the butterfly cluster. So it is an estimated 100,000 years old. Now, most of the stars you see in this cluster are relatively young. They are hot. They are blue in color. In fact, blue and blue-white stars are the hottest type of stars. Now, in good viewing conditions, you can see this cluster without a telescope, but with the help of binoculars. So here is another image of the butterfly. Little V shape there. Take a look here again, if you can bake that into your brain there. So there's little antennas right there. Ooh, right there. So there's a large V up there. And there it is. There's three. The antennas right here. And there you go. So there's the wings of the butterfly for the butterfly cluster. So this is an open cluster, an open star cluster. Now, an open star cluster forms within the same molecular cloud. They can contain about a dozen to about 1,000 star members. Now, the stars you'll find in these deep sky objects are typically loosely spaced, and they are generally younger and hotter stars. So I'm going to find a different one here using a different program. Let's find something called M8. I'll show you the constellation of where it's at. Oops, I want to go that way. So here we are at Sagittarius, and see how these borders here, all the constellations have these borders. These are the IAU, the International Astronomical Union borders. This is the boundary that is for Sagittarius, and you'll see the teapot of Sagittarius, for example. Let's see if I can find M8 here. There's the teapot, there's M8, but I want to view it with this program here. So we are traveling out to M8 right now. So the butterfly cluster was an open star cluster. This we're going to change up a little bit here, and we're going to view something called a nebula. This is the Lagoon Nebula, or M8. Let's kind of orbit around here and take a look at what this looks like. Almost like a big ball of cotton candy. So M8 right there. Let's zoom in a little bit to see this here. All right, there's M8. Same thing, just a different type of perspective here. So star clusters can be found all over our galaxy, but I think the nebulas that we have out there are much prettier to look at. They're very colorful like that. Now, with this particular nebula, we're going to get two for the price of one. Not only do we see this large area over here, this large bright Emission Nebula, but there's also an embedded open cluster within it right there. Now, whenever you look at it here, let me put my coffee down. Again, same image. There's that reflection nebula right there. Open cluster inside there. So whenever you look at it here, you'll see that it looks as though it's cut in two with this dark lane dividing it. I think you can see my cursor here. Well, this is the lagoon portion, and this is how it got its name. Now, that whole dark band extends about 25 light years. Well, the Lagoon Nebula is about 4,100 light years away from Earth and is currently undergoing a period of active star formation. Let's look at it again from this point of view. So you can find this just above the right of the teapot of Sagittarius, right there, right in that little region. In fact, so there's the bow of Sagittarius. So right in the crook of that bow, you can find. Oops, there you go. You can find M8. So in fact, this whole region here of space contains a number of notable deep sky objects. The other one I wanted to visit right now is called the Trifid Nebula, because it has this really cool dual color tone to it. So you can find the Trifid Nebula right above, right there. So we are just right there. Now we're here with the Trifid Nebula coming in. You see how it is that reddish pinkish area and this bluish area right there. Let's go visit it up close over here. Trifid Nebula right there. Let's go to that. So we're heading out to the Trifid Nebula right now to see what I am talking about. So this nebula too comes in two parts. But this nebula has one part that is an emission nebula and one part that is a reflection nebula. Now, whenever you see the two color tones, you will see what I am talking about. You can probably guess where the dividing line is at. Here we see it in 3D space there. There's that reddish pinkish area. There's that bluish area right there. Well, the emission nebula is the bright red over here. The reflection nebula is the bluish, the pale bluish area. Well, it looks kind of like the cotton candy that you get at the fair, with one side being pink, one side being blue. Well, there is a theory on why these have different colors. Let's take a look at it from over here. There we go. Actual photograph of the Trifid Nebula here. So the theory of that we have two different colors is because the red portion of the Emission Nebula is the light from the hydrogen atoms. Blue reflection nebula is dust reflected back in the starlight. So there's also a dark nebula, this dark region here silhouettes the light that is beneath it. So what is an emission nebula and what is a reflection nebula, you might be asking? Well, an emission nebula is a nebula that shines brightly naturally as compared to a reflection nebula that is lit up by the light from the external source, which would be the stars in this case. Now, you're probably wondering what a nebula is. Well, a nebula is a giant mass of cloud and dust that can be light years across. Now, these objects of gas can mark the beginnings of or the endings of stars. Let's move on from this area here. Going over a couple of nebulas, or nebulae. Because now we can find some animals in our nighttime sky. We can find something called the Swan Nebula. Right there, and then we can find something called the Eagle Nebula right above that, and then we can find something called the Wild Duck Cluster right above that. And there's a little constellation artwork there. So let's go back to the Swan Nebula that I just talked about here. Zero in on that, take a look at this up close. Swan Nebula. All right, so it's called the Swan Nebula. Cock your head a little bit to the left here and see if you can find a picture of a swan in that. So do you see a swan there? Yeah, really look at it. Maybe squint your eyes a little bit. Most people see a duck here, but anyways, if you're having trouble seeing a swan, here is an artistic representation of the Swan Nebula. Ooh, that's beautiful. The bent, curved neck of the swan right there. Now, if you look at that, take a look at it over here, and again, you have that swan neck right there. So now you're kind of getting a little bit of a sense of the swan figure here. You got the swan neck there. Maybe this is the wing. Maybe that's the body and the water. They look at these things for a long time, and finally they start to see these objects. Well, that is the Swan Nebula, or M17. So this is a rich stellar space, and this curved region here coming from the western end of that nebula. Well, also we have the Eagle Nebula. I like this one because there is a hidden little gem inside of it. Eagle Nebula right above that one. Now, can you see an eagle inside that? Maybe bend your head to the right. Do you see an eagle? Well, this is M16. Oh, by the way, the M in these names, M16, M17, M8, M6, the M stands for Messier. These are Messier objects, after Charles Messier, who was responsible for cataloging most of these deep sky objects, particularly the ones that were visible to the naked eye in small telescopes. Well, this one here is the Eagle Nebula. It's kind of an eagle-like. You have the head here, and you have the wingspan of the eagle. Now in this, you can kind of see it right there. That is a very famous configuration called the Pillars of Creation. Now Hubble took a picture of this. Oh, there you go. That's the Eagle Nebula right there. Again, actual picture of the Eagle Nebula. And that is what I just pointed out, the Pillars of Creation. And you've probably seen this picture around. I've seen this actually on a couple of album covers. Also, there is the Wild Duck Cluster. Take a look at that. Right above that, over the constellation of Scotum. This is also the location of the largest star that we've discovered that I was talking about a little bit earlier before the show started, the UI Scuti. Look at it here. All right, this is the challenge. Can you find an image of a wild duck? Okay. Well, if you can't, I will help you out a little bit here. This cluster is several hundred visible stars, all packed into a very small spot here. A small spot of sky. It's quite a large area of space. Now this area of sky is about the size of the moon. This is also known as M11. So here's a little bit of help of the wild duck cluster. So you have this string of stars, and you have this V shape of stars forming the wingspan, and then these three down there. So let's see if we can find that in that depiction here. I think this is it right here. That three stars there, that V there, and then that little collection down there. I could be wrong. It's a very fuzzy picture. But that's the wild duck cluster, and the 19th century British astronomer William Henry Smith declared that this represented a flight of wild ducks. You can see this V shape of stars there. That was what he was talking about. Oh, you can find these all along the path of our Milky Way galaxy. And speaking of the Milky Way galaxy, there is something that we can find in our Milky Way, right here in the bulge of the Milky Way, right in Sagittarius, called Sagittarius A. This is a very cool... All right, right there. So you'll see that big bulge that is the bulge of the Milky Way. In that is... I'm going to actually go to a different program to show it, but this is the believed area that we have a... I won't tell you until we actually get there. So, there is Sagittarius A. There's the constellation it's in Sagittarius. Let's fly out to it. Going through the edge on of the disk of the Milky Way galaxy here. As we approach this section of our Milky Way, we will soon see that it is actually the black hole at the center of our galaxy. Boom. All right. So let's speed up time to see the spinning gas, dust, and stars along this path here. I will. Okay. There we go. Let's dial down the exposure just a tad. It's very bright. There we go. So let's approach this area here. Carefully. Oops. A little too fast. Okay. There we go. Just kind of orienting ourselves so we can see the gravitational lensing. All right, cool. Looks good. So this is Sagittarius A, the black hole at the center of our Milky Way. So now we can't actually see the black hole at the center of our galaxy. There are stars, dust, debris, gas, etc., all in the way, making it very hard for us to see through all that stuff to actually see this object here. This is an artistic representation, a CGI representation of Sagittarius A. Well, this proposed black hole is located about 26,000 light years away from us. And they believe a black hole is here because the stars are orbiting this area much faster than the other stars in the Milky Way. Now, astronomers have calculated its mass to be about 4 million solar masses, and the only kind of object that can be that massive, this area, not only in that massive, but have the radius of about 100 astronomical units, be a black hole. So Sagittarius A can be found within the constellation Sagittarius, like I just showed you, and it's part of our own Milky Way galaxy. But we can also find other galaxies in our nighttime sky. I do want to point out something here before we leave this area, this gravitational lensing. Watch this star behind as I orbit around. You'll see it goes over like that. That is because the gravity of this black hole is so intense that it is actually warping space itself. So the light that is coming from behind it is having to go over, it's being warped over this black hole area. So that's why this bulge here, that is due to that gravitational lensing. It is actually, you're actually viewing the disk that is behind the black hole. It's a visual trick, I guess that you could say, from the gravity of this black hole. That is why the black hole in the film Interstellar was so accurate, because it called into the actual gravitational lensing that black holes do. So, yes, this is the black hole at the center of our Milky Way. So let's go back home, because there are some other galaxies that we can find in our seasonal summer sky. All right, so here we are back on Earth. Great. Well, we just had July 4th, Independence Day, so in honor of that, let me show you something called the Fireworks Gallery. The Fireworks Galaxy. Way over here, just below Cygnus. Now, last show, we dealt with the Summer Triangle, which is the Aquila the Eagle, Lyra the Harp, Cygnus the Swan. There are those names. And the Fireworks Galaxy can be found right there. If we zoom in, we'll see it. But let's go to this program to look at the Fireworks Galaxy. Actually, let me put in its proper name here. Leaving our own galaxy to see the Fireworks Galaxy up close. Well, this galaxy is about 22 million light years away from us. So whenever we look at it through a telescope, we are actually seeing the galaxy as it was 22 million years ago. So it's mainly called the Fireworks Galaxy. Now, the streamers that you would see here, this is the result of its birth here. It's not called the Fireworks Galaxy because of these streamers. It's called the Fireworks Galaxy mainly because it has an unusually high number of supernovae that have been found in this area. Now, so far, 10 supernovae have been discovered here, or observed here, actually. Now, in comparison, our own Milky Way sees about 1 supernova per century. So this is kind of odd because our Milky Way galaxy has about twice the number of stars than the Fireworks Galaxy, but the Fireworks Galaxy has far more supernova that's going off. Now, last I want to talk about something that's not quite a deep sky object. It is an exoplanet, but I found out about this planet and I thought there's an aspect of it that was really cool. So since we're kind of going far out into space, let's visit an exoplanet. An exoplanet is a planet that is orbiting a star that is not our own. So an exoplanet far out in space that has its own solar system, its own star, and an alien world. So let's go visit that up close because there's something really cool about it. B. Go visit you. And we're going to take a look at where it is at. There's it. It's also in the Pisces. Actually, for some reason I thought that Fireworks was in Pisces. Fireworks is right below Cygnus. WASP 76b is right below the Pisces constellation. So let's go visit that. WASP 76b. Again, if you look up here on the screen, upper left-hand corner, that's the name of it right there. Now, this is a hot Jupiter, as they call it. Now, I wanted to talk about this because something really cool is happening on this exoplanet, a planet which orbits a star other than our own. Let's back away from it a little bit so there it is up close, this hot Jupiter. There's its star. I'm going to speed up time just a bit so we can see how it... By the way, here's a look at it in relation to its star. So there's WASP 76b. Why is that so interesting to me? Well, it is cool to me because on this planet, it rains iron. So this planet is slightly smaller than Jupiter and is about 640 light years away from Earth. Now, it can be found in the constellation Pisces I just pointed out before we got here. But since WASP 76b, or WASP-76b, since it is so close to its star, it is tidally locked, much like our moon is tidally locked to us. Now, the reason why it's called WASP 76b, this would be WASP 76a, the star, and then B is the next planet. So, not the next object to it, for example. Wasp at 76, and then you have B. Just throwing that out there. Well, since it is tidally locked, the day side always facing the star is constantly baked with intense radiation, so much so that it's hot enough to vaporize metal. And the winds driven by the extreme temperature differences between the day and the night side push the vaporized metal around the planet to the night side hemisphere, causing it to rain iron. So by the way, the band Iron Rain's playing next week at the Varsity if anyone's interested in seeing that. That is a joke, but since we're here, I'm kind of curious to see if there's actually a band called Iron Rain. I don't know. Let's see here. Iron Rain. And there's a song called Iron Rain by Vader, Polish band. And there is a band called Iron Rain. Look at this. Did I call it or what? Iron Rain. Look at that. Okay. All right. So there you go. Actually, there are two bands called that. All right. Well, it's a terrible band name. But folks, that is going to do it. A little bit of a side there. That is going to be, I'm going to go ahead and call it. That is the end of the show here. So we did some deep sky objects. We saw some nebulae. We saw some clusters. We saw an exoplanet, some galaxies out there. So that is what you can find if you have a nice telescope or even some binoculars that you can find and take a look far beyond our planets to see some deep sky objects. I hope you enjoyed this little tour of our nighttime sky. I think next week I'm going to do a show on Star Wars, possibly taking a look at the fictional worlds in Star Wars and comparing them to actual exoplanets and planets even in our own solar system to see what it would take to have a planet with two suns or a planet like Mustafar, which is a lava planet. So I think I might do something like that next week. So stay tuned for that one if I can get it ready in time. But other than that, have a great rest of your evening. Good night, and see you next week.